So we're doing question number 25 from homework number 3. The question says, two in-phase speakers 2 meters apart in the plane are emitting 1800 hertz sound waves into a room where the speed of sound is 340 meters per second. Is the point 4 meters in front of one of the speakers perpendicular to the plane of the speakers, a point of maximum constructive interference, perfect destructive interference, or something in between? All right, so first we're gonna write down all our knowns. So we're given frequency of 1800 hertz, and that's from both speakers, or each speaker has that frequency. We have the speed of sound in that room is 340 meters per second. And we have the point in front of one of the speakers, which is 4 meters in front of it. We're also told the speakers are 2 meters apart from each other. Call that X. Okay, and then so what we're trying to find, ultimately what we're trying to find is the phase difference. And in order to find that, we also have to find the wavelength and the difference in x distance between the two waves coming from the speakers. So now we're just gonna draw the diagram of what's going on. We have speaker A right here, and we have speaker B over here, and they're 2 meters apart. And then we're gonna have point P 4 meters in front of speaker A. And so now we know the distance from speaker A to point P is 4 meters because that's what's given. And now we got to find distance of speaker B to point B. And for that, we're just going to do Pythagorean theorem. And so we're given 2 squared plus 4 squared equals c squared. And that's just going to give us square root of 20 for distance c, which is the distance from speaker B to point P. So now we're going to find the difference between the two distances to the point P of the two speakers. So for that, now we just do delta x, and we do 20 minus 4. Okay, so now we can find as well lambda, which is velocity over frequency, and then we're given velocity is 340, frequency is 1800. Actually, we'll plug that in at the end of the formula. And so now we have what we're really trying to solve for, which is the phase shift. And so that formula, 2 pi lambda plus the inherent phase shift, which since they're both in phase, this is just 0. So now we can go ahead and plug everything in. And so we can plug in our delta x, 20 minus 4, over lambda, which is 340 over 1800, And now you can solve for that. Okay, and this portion of the equation comes out to be roughly 2.5. Exactly, it's 2.499. So we got 2.5, and that times 2 pi was 5 pi. So now our phase shift is of 5 pi. And since we know that the wave started in phase together, if we look at our unit circle, if both waves started together and the phase shift is of 5 pi, we go 2 pi, 4 pi, 5 pi. So that means that there's a net phase difference between the two waves of pi, and that would have the waves forming perfect destructive interference as the max point of this sine wave is is being destructively interfered with the minimum point in this wave over here, which that means that this wave will look something more like this. All right, yeah, there you go. That looks better. All right, so answer for this question is total destructive interference. All right.